This is a follow-up of the previous video about multiplication of monomials. So we're going to still do the area method for this problems. Okay, so on this example I'm having here, it looks like I have a monomial outside the parentheses. So I have one term, and this is multiplying 1, 2, 3 terms inside the parentheses, right? Terms, remember, they're separated by plus and minus signs. So instead of doing a regular rectangle with one monomial in here and the other monomial in here, what if we do just one rectangle, but we split it in several areas? So we're going to find the area of each of those rectangles separately, and then we're going to add all of those up. So why am I dividing in 3? Because I have 3 terms outside inside the parentheses. So I'm going to place each of those terms as a part of the long side of the rectangle. So the first term is going to go 3x to the power of 5. The second term is going to be negative 5x squared. Remember that they carry over their signs. And the last one is going to be positive 7. And this monomial that I have outside the parentheses, I'm just going to place it on the small side, which is going to be 6x to the power of 3. So it looks like I'm doing a multiplication of a monomial times a monomial 3 times. So I want to find these 3 areas over here. So let's see what the area of the first rectangle is going to be. So the first one is going to be 6x cubed times 3x to the power of 5, because the first square has or rectangle has a height of 6x cubed, and it has a length of 3x to the power of 5, right? 3x to the power of 5, 6 cubed. And then to this, I have to add the area of the next rectangle. So let's try to find the area of the next rectangle, which has a height of also 6x cubed, but this one has a length of negative 5x squared. Remember, these are not additions or subtractions, right? We're multiplying. And then for the last rectangle, it has also a height of 6x cubed. That's my height. And it has a length of 7. Okay. So let's find those 3 multiplications separately, and then at the end we can just add them up or combine them, merge them together. Not really merge them together, but just write them all together. So for the first multiplication, we're going to multiply the numbers first. So that is 6 times 3. And then the variables, that's x cubed times x to the power of 5. So 6 times 3, that's 18. X cubed times x to the power of 5, that's x to the power of 3 plus 5. So we will have to add those two together, add those exponents. For the second rectangle that I have in here, I have to multiply the numbers first. That is 6 times negative 5. And then I have to multiply the x's. So x cubed times x to the power of 2. So if I multiply the two numbers here, 6 times negative 5, it's negative 30. Then x cubed times x to the power of 2, that's x to the power of 3 plus 2. We have to add those two exponents, so the result should be negative 30 x to the power of 5. And for the last multiplication, or the last area, that's going to be multiplying the numbers, so 6 times 7 first, and then times the x cubed. So x cubed doesn't have anything to multiply with, it would just carry over all the way to the result. So 6 times 7, that's going to be 42, positive 42, x to the power of 3. So that should be my final result. And this whole thing is my result for the whole area of that rectangle. 18 x to the power of 8, negative 30 x to the power of 5, or minus 30 x to the power of 5, same thing, plus 42 x to the power of 3. So if you multiply the starting example, right, the starting point over here, if you multiply this monomial times that trinomial or that polynomial, the result is going to be 18x to the power of 8 minus 30x to the power of 5 plus 42x to the power of 3. And of course, we don't combine like terms because none of those is a like term. They have to have the same variable with the same exponent in order for us to be able to combine those. Another example that I'm going to show you, it's really similar to the previous one. That's 6x to the power of 4. And to this, the monomial is going to multiply 2x to the power of 5 minus 3x squared plus 4. So let's do the same thing. Since I have 3 terms inside the parentheses, I'm going to divide my rectangle into 3 smaller rectangles, since I have 3 terms inside the parentheses. Outside the small side of this rectangle is going to be the monomial, or the term outside the parentheses. And then on the top of this rectangle, I'm going to start placing all of my terms that I have inside the parentheses. So the first one's going to be 2x to the power of 5. The second one's negative 3x to the power of 2. And the third one's positive 4. And this is, we're going to try to find those 3 areas and then add them up or write them together. Okay, so for the first area, it's going to be the length over here, that's 6x to the power of 4 times the length, which is 2x to the power of 5. That is the first area. For the second area, this is going to be, the height of the area is 6x to the power of 4. And to this, I'm multiplying the top side, which is negative 3x squared. So times negative 3x squared, which is my top side. And then for the last one, there's going to be the height, which is also 6x to the power of 4. And this I'm multiplying times the length, which is 4, so times 4. I'm going to use those 4 different multiplications. So let's find the area of the first rectangle. Multiply the numbers, so 6 times 2. And then multiply the x's, which is x to the power of 4 times x to the power of 5. Multiply the numbers, multiply the letters. So this is going to give us a 12. 6 times 2 is 12. X to the power of, and you have to add those 2 exponents. So the final result should be 12x to the power of 9. That's for the first area. I'm going to write the area already. That's 12x to the power of 9. The second area, or the second multiplication, I'm going to multiply the numbers, so 6 times negative 3. And then multiply the x's. X to the power of 4 times x to the power of 2. So regular numbers multiply normally. 6 times negative 3, that's negative 18. And then x to the power of 4 times x squared, you have to add those 2 exponents. So you add those 2 exponents, the final result is going to be negative 18x to the power of 6. If you add those 2 exponents. Now for the last area, same thing, you have to multiply the numbers, so 6 times 4. And then you multiply the letters, x to the power of 4. So 6 times 4 is 24. X to the power of 4, that doesn't have anything to multiply with, so I'm just going to leave it as it is. The result, positive 24x to the power of 4. So it looks like I found my other components of the area, negative 18x to the power of 6 and positive 24x to the power of 4. So it looks like that is going to be my result for multiplying a monomial times a trinomial again, which is 12x to the power of 9, negative 18x to the power of 6, and positive 24x to the power of 4. So that is my multiplication. Another indicator that I like to do that comes in handy also is seeing that outside the parentheses I have one term. And this is being multiplied times, how many terms do I have inside the parentheses? 3. So you multiply one term times 3 terms, the result has to also have 3 terms, since I'm doing a multiplication of 1 times 3 equals 3. It's an indicator just to make sure that you're not coming up with extra terms or more terms than what you need, right? If you multiply 2 terms times 2 terms, you have to have 4 terms at the end before you combine any like terms. If you multiply 6 terms times 6 terms, then that means you have to have 36 terms at the end of the multiplication, at the end of the distribution of all of these areas. So keep this in mind, right? It also applies for binomials. You have 2 terms outside, 3 terms inside. You should have 3 times 2, 6 terms at the end of the multiplication, or at the end of the distribution of all of these areas.